Okay, dear colleagues, I hope that you can hear me. This is Alex Kotsev from the Joint Research Center. First of all, allow me to welcome you all to this session. Before starting and diving into the very interesting, cool details that we have to share with you today, some information about the logistics. First of all, as Kathy just mentioned, we would like to thank you in advance for keeping your microphones shut muted all the time and to turn off the video to just preserve the bandwidth. If you want to be asking questions, right next to your name in the list of participants, there is the raise hand functionality. Use that. We also would like to encourage you to extensively use the chat of WebEx. We will not be able to immediately react to your questions in the chat, but for sure we will address them when the opportunity arises. Final comment from my side. This session is being recorded and the recording will be made available later. So, with this having been said, over to you, Kathy, for introducing our workshop. Thanks.
Inspire context. If I've been muted or unmuted now, I had unmuted myself.
I can hear you well.
Okay. So back to the present. What is this? What are we doing? So we're going to start with why APIs in Inspire. Then I'm going to give you an overview of some of the project details. Then we're going to start diving deep into the two APIs we're currently evaluating. The one is OGC API features, more for the spatial domain. The second is the OGC API sensor things API. This is more for dynamic measurement data. And then we'll show you the various data sets we've been putting up within this project. We've been referring to them as data nests, because we've always been looking for groupings of co-located data that one could somehow aggregate together. So there we've got a nice collection of what we've been calling Area Austria. We've got some very interesting smart city sensor data coming from Hamburg. We've got a nice cross-border area between France and Germany providing water data. And then we've also got a nice ad hoc data set, which has been triggered by the current COVID crisis. So you'll get details and all of that. And we'll wrap up with trying to see how can we use this data? How do we take it forward? So for an overview, why do we want these APIs in Inspire? I'll hand back to Alex. He's Mr. Commission. Will tell us why the EC thinks that this is a good idea. Alex?
Thank you, Kathy. Indeed, I will try to be as short as possible here because I think we have a lot of really cool stuff to show you today. So I will set the scene really briefly. So why APIs in Inspire? First of all, if you look at the majority of the download services that are made available by member states in the Inspire Geoportal, you would see that they are actually following this previous version of standards. So you see a lot of WFSs, quite a few atom feeds, but not so many APIs. At the same time, there is lots of interest in APIs. By the Inspire community. We intercept that through different channels, but very few implementations of APIs that are declared explicitly under Inspire. And what we also see that there are different approaches, different encodings, documentation standards. Last but not least, of course, going the API way requires some costs, but also, yeah, of course, there are benefits. Those are not very well known. On the political level, we have currently a very interesting development, the political priority as defined by the newly launched in February European strategy for the data that defines sector-specific data spaces with the idea to interconnect the different actors in the data economy, starting from the business, the public sector, but also citizens. As well, we have the Open Data Directive, which has defined the concept of high-value data sets. The directive also mentions that those high-value data sets still to be decided in terms of thematic, which are they exactly, but the directive already mentions that those should be made available through application programming interfaces. And we have also the new working program for the Inspire MIG. There is a lot of discussion also within that context about APIs, about standard-based APIs in particular, that can be seen as one of the means for modernizing the Inspire technological stack. Next slide, Kathy, please. Thank you. So, in a way, there is a very excellent context, both on the technical and the political level for APIs and for Inspire. They can increase the use of the infrastructure because, I think we have had this debate in Inspire about blending more into the mainstream ICT world, and then I think our core customer for Inspire would probably be the developer, and developers nowadays, the first thing they would be looking for probably would be a well-documented API to start working with. In addition, standard-based APIs can help us improve the discoverability. We have the data on the web best practices and the spatial data on the web best practices. Both of those best practices explicitly mention the use of APIs. And last but not least, I think we can leverage on the grassroots standardization initiatives. We have seen a very nice, novel, positive approaches in standardization bodies, the OGC in particular, and I think the two standards that we're discussing today, the OGC API features and the Sensor Things API, are excellent examples in this sense, because now I think the way in which standardization works, and which we welcome very much and try to support through the hackathons, through accommodating the user needs early on, is very positive. We see also that there are multiple early implementations even before the standards are being endorsed, and then a lot of actors actually help for the co-creation of the specifications. So exciting times, I think, for APIs and for using them within the context of Inspire. Can you move on to the next one, Kathy, please? So within that context, we have the API for Inspire project, which is implemented under the ISA² ELISE action, ELISE standing for European Location Interoperability Solutions for e-government. So in the way, the overarching context is to empower governments in order to do a better job with interoperability in the geospatial and the location domain. And actually, investigating APIs in ELISE was required by member states. There is the ISA², there is the working group under the ISA² program on geospatial solutions, and within that group, member state representatives asked us as Commission to do something about APIs, and this is how the project was conceptualized in order to actually understand what are the benefits, what are also the efforts involved in establishing APIs for Inspire. And we have conceptualized this as a really novel approach. So we wanted to really couple the project team. You will see what is the composition a little bit later, but to couple the project team with data providers. And I know that now with us there are in the audience some of our data providers, and I take the opportunity to thank them all and hope that they will be sustaining the nice results that are achieved even after the end of the project. And then we wanted to also have a hands-on experience, so to really work on getting the hands dirty with the APIs and going through the whole process, looking at the provider side, but also looking into the user side. And there is an evaluation methodology for the APIs that is measuring exactly this, the costs, the benefits, and the effort. And then there are, with all the different providers, different deployment strategies for the API. So to understand what actually works, what doesn't work, and under what particular conditions. And then there will be guidelines, summary of lessons learned that can actually help empower all the data providers and users in the Inspire community who are interested but don't know really how to go for APIs under Inspire. And in the end, there's also the concept of Inspire good practices, where as a community-driven initiative, those would be, the idea is that there is evidence for new technology that can work for Inspire, and that in a way is somehow endorsed by the Inspire MIG. The idea would be to collect all the evidence from this activity and help for the submission of such Inspire good practices for both the OGC API features and the Sensor Things API. Next one, Kathy, please. So I think over to you now, Kathy. I think this is from me for the time being for the introduction.
This is our first handoff point. Okay, so getting to the actual project objectives. Thank you, Alex, very much for the big picture, how this fits into the European context. So what are the objectives really of this workshop? You know now a bit about the API for Inspire project. But what we're now trying to do is start disseminating this information. So what we're going to try and do is to, first off, explain and demonstrate both of these new API types. I think there's been a lot of buzz around it, but a lot of people are not really aware what are we really talking about. So you'll finally get to see what are these things, how do they work, where can I go and play with them. The playing with it goes seamlessly into the next point of providing information on the various endpoints which are being made available by this project. One of our goals is to make as many different data sources as possible to expose them this way, and then let various people see how good, bad, ugly is this? Is this what you want? So going off to the third point, we'd like to collect feedback from all of you, both now and in the future, on where you see both strengths and weaknesses of the various APIs we've been making available. And finally, we'd like to identify some member states willing to participate in establishing these Inspire good practices. Alex already mentioned them a little bit more on this. This seems to be how Inspire will in the future evolve. We're all used to waiting for the commission to create new guidelines, how we must do things. And these days are over. It's getting more and more to the level, Alex, correct me if I'm wrong, but the way I've been understanding it, it's getting devolved down to the member states. If the member states have a good idea of how to do this, which is fulfilling the legal requirements, they should band together and set up what is called a good practice, show how this solution fulfills the Inspire requirements, and then basically they're good to go. So we're very close on getting this set up for both the OGC API features and for Sensor Things API. What we're missing on both fronts is a few more data providers willing to play along, expose their data so it can really show this is sensible, this is viable, this is being used, please use it. So we'll be asking for volunteers at the end. Now to continue on with explaining the project itself. So we've got the core project is the 3 project partners you see on the slide in front of you. Lead of the project is Fraunhofer EOSB. They're the ones who developed the Frost Sensor Things server. I'm involved via Data Cove. I have many, many years of Inspire and just general environmental data expertise. And the third organization of the group is GeoSolutions as the developer of GeoServer. And they are wonderful experts on the OGC API. So between the 3 of us, we have this field nicely covered. To complement this, we've then added various data providers. These are from various thematic organizations. Most of them are required to provide data under Inspire and are curious to see how can they do this in a more useful manner. So I'm trying to see, is there a sensible order here? I think it's ordered the way I had it ordered on the website. It starts with the Austrian Meteorological Agency providing meteorological data. There we have co-located data from Control, which provides the Austrian air traffic network. So there one could do interesting use cases on meteorological data and air traffic. The second grouping is the Austrian Environment Agency and the European Environment Agency. This was actually an ad hoc activity which wasn't initially planned, where based on various COVID research outcomes linking COVID intensity with air quality, I realized I know where the air quality data is. It is there. It's very hard to get a hold of. And we did a quick ad hoc activity. Now we've got most of European air quality online in real time. You'll see the endpoint soon. Next on the list is the city of Hamburg. They are doing stunning stuff towards smart city sensors. And we're very happy to have them involved here because they're not just experimenting, they're really using it and doing it and making Hamburg a more interesting place to live. Then the final 3 are all participating in our cross-border French-German water pilot. There we've got the French Geological Survey, BRGM, as well as the French Office for Biodiversity. And between them, they share the Inside Environmental Information Systems Research Center, which has been really trying to push the envelope of how can one provide this type of environmental data in a simple but structured and sane manner. They cover the French side of the water data, and on the German side, we've got the Environment Agency of Baden-Württemberg. They're providing the German view of water data, and there we've got all the river networks, we've got the groundwater bodies, we've got surface water groundwater quality, quantity, basically anything you can do with water we have there on both sides of the border. Really interesting will be where it now overlaps, because it turns out the French have German data and the Germans may have some French data, so we hope we don't start a new war and try and harmonize them. Okay, that's our data providers. Next step is going off to explain what is this OGC API stuff. For this, I will hand off to Sylvain.
Is that better with the sound? I guess you hear me now. Can anyone confirm I'm being heard? Yeah.
Yes, we can.
Yes.
Okay, sorry. I was double muted on the phone as well. Hi everyone, so Sylvain from BRGM. And yeah, a bunch of quick slides on OGC APIs, and I think I already shared links in the chat for more information. What newcomers have to bear in mind is those new OGC APIs we're talking about are a major change, a major turn in OGC specification. And previous well-known ones like WFS and Sensor Observation Service were based on design from the 90s and early 2000s. There was an uptake by several important infrastructures like Inspire, but data served this way was highly underused for many reasons, which I don't have time to develop here. it was also underused by the web community, and we were seeing on the side RESTful approaches popping up and development of protocols and framework like OData and Swagger and OpenAPI. So things started to change around 2013, 14 when W3C and OGC started to collaborate even more together. So yeah, we have new APIs to play with. So I kind of already went through a couple bullets. Many of those new APIs are identified under the common banner OGC APIs. They are targeting behaving as RESTful services, being described by things like OpenAPI documentation, and they target, I would say, JSON family-based representation, JSON, GeoJSON, friends, and other encodings are supported. One is HTML, so you can do GML if you want, with some flavors. The rationality of those APIs also to be specified with minimal core for easy, fast implementation, being progressively extended to add functionalities. Next slide, please. Yep. So under the OGC API common, it was like OGC Web Service AWS common before. You have a specification that is available under the GitHub that identifies clearly those various resources, like the landing page, or the API declares its conformances, various collections and stuff. Also, the emphasizes some encodings here. Can you go to the next slide, please, Kathy? Yeah, one of the main change is that in those the way the specs are designed is there is this purpose of providing links everywhere. So the service describes itself through links and the resources are provided. The data instances are actually a lot linked together. So it means that the client has actually almost all it needs to continue interacting with data set and the API and reducing the overhead or going like RTSM, just open the 200 pages manual and code your own client. Just you can really get bootstrap pretty fast. So it's really 8 OS oriented and this flavors of new web approaches. So this is an example where that collection is linked together. You got at the bottom right an example of the link to this. How do you refer to me? This kind of stuff. Next slide. Please. So what is important as well is that very little is mandatory in being compliant. So that's really a different way of tackling the topic compared to what we did the previous generation of OGC specification, and also the way it was, cascading down to what was in Inspire Network Services regulation. So yeah, let's say none of the encodings are mandatory, and server could also provide an XML protocol buffer, still claim compliancy. The usage of OpenAPI is suggested, but not mandatory. Also, yeah, that's something I said already. A client could really fast and easily work by following the links that are provided by the API, API operations, and also for the traversing to more information, to fetch more information. And yeah, we kept it, but Bart strike through it. That's not the way of the modern web. That's the way of how the web was designed in the first place, linking resources. And yeah, how does the client work then? Then just need to check the conformance declaration at the flash conformance, for example, on the OGC API aspects. That's one, yeah, OGC API example. Next slide, please. So building on OGC API common, one is features. And there are other sessions in that conference where you also have records and stuff. So this is the GitHub to OGC API feature specification. So in addition, that's really important to what's been defined in core, you have the definition of the link to resources like item ID. First glance, people could say, yeah, it only supports a limited number of CRSs. Yeah, right. But there are extensions, if you look on the right side of the slide, that are already being progressively set up, and one is includes how to handle more coordinate reference systems, one of filtering, etc., one of them transaction, so transaction like replacer of WFST, and another aspect in the seek for quest for simplicities are non-mandated schema. Feature can be anything, so simple feature 0, 1, 2, no E, and it could be even something complex, like something that was defined in Inspire. So it reduces really the entry ticket, and other exercise you'll see in the slide tries to find the right balance between no mandated schema, but still providing data content with a bit of semantics. And I think that's all for a really quick check. There was a link in the chat if you want to fetch really more information. I think that's Nuno's then.
Yes, thank you, Silva. So sharing my screen. Okay, that was a very nice description of the OGC features API. So basically, I will do two things. One of them is that basically I will demo with real server that is actually using bearish and data Warhorse use case, showing a bit how that OGC API works in practice. So clicking on things, and then I will explain a bit more in detail how things work in GeoServer. Okay, so well, as it was mentioned on the previous slides, so well, the OGC API is an umbrella for a few other APIs. Here we'll be focused a bit on the features one, and here we go. So in the previous versions of these services, let's put it that way, I like to see them as a continuation. For example, the features, the continuation of WFS, because some of the concepts are similar. So it doesn't matter which technology we are using. At some moment, we need to tell the external world, look, these are what I offer. Sorry, these are the capabilities I offer. So the services, the methodology, the endpoints that are available, and this is the data I offer. So on OGC features, this is done with the API document. So we can go, remove just this WebEx things, there we go. So we go to an Open API document, which describes what endpoints our server makes available. So a client can query this and know, well, how to interact with our service. In this case, well, we have the API endpoint, which provide this document, which describes the conformance, which explains what our server is actually capable of offering. So if I write it, there we go, it can be in JSON, and we can see that our server offers several capabilities. Then we have the filtering capabilities, actually a new extension point, so we'll not go through it. And then, of course, we have the collection. So the data we have available on our server, so we can come here to the main page and we can go to the collection page. So OGC features, collections. Here we go. In our site, we have two collections. We can actually ask for a representation in JSON, which is nicer for computers. And again, here I would like to mention two things. So the structure of these documents, we can see that linking is everywhere. So this document provides the links to the representation of this page itself. Okay, so I may want to see this in YAML, which actually I will not open, in HTML, which we saw before. And then we have actually the collections themselves. And for each collections, we have a different type of representation that's available. So if I want to see my boreholes represented as LD JSON documents, I will click on this link. I already opened this one because it takes a bit. So for example, here we can see the, sorry, oops, there we go. So here we can see, actually, sorry, here we can see the LD representation of that collection. So nothing else as a representation of that data. Then we can also have the representation, for example, on GeoJSON, which was the one I was showing at the beginning. So it looks like this. Actually, sorry, I messed up my links. There we go. So this is basically the way it works. So we get the document and we get the links to move to the next step. And at the end of this document, here we have another collections. Why? Because, well, we have two collections. So if you have 100 collection on our server, all of them will appear here. So that was one of the things. And now if we go again to our API, we see that the next endpoint we have is, well, the collection itself, which is basically what I did when I click on those representation. So here I can see the collections endpoint. I click on my collection and I get the representation. So this is the nice thing about OGC API features. So when we actually need to start integrating with the server, we get an endpoint, then we get documents, which gets the links for the next documents, and so on. So this makes all of this integration progressive and a lot more easier to implement. And then there is also the development world. So the people, as well, like me, who are on the other side, they need to implement applications which will need to interact with these APIs. And these new ways of representing the data, typically the GeoJSON encoding, works very, very nicely with modern collections. So now this brings a question, because, okay, we are here. So we have three sides here. So we have the group of people who need to create models for the data. So I have a real world use case. I need to create a model. So an IT model that represents this and that can be shareable. Then we have the group of people in the middle that needs to implement middleware, so software, which is capable of reading that model from a database and to make it happen in a certain format. So in this case, for example, we can read from a relational database.
You know, your sharing.
Sorry?
Your screen sharing stopped.
Ah, sorry. Thank you, Sylvain. Sorry, Ilke. Can you see it now?
Yes,
Yes, we can.
Very good, thank you. No idea what happened. Okay, sorry about that. So I was basically, well, so, okay, so we have an OGC API features that's a very new modern API, and one of the main benefits it brings that it will make a lot easier for the people at the end of the chain, the ones who need to actually consume this data from these web services. They will need to, well, they will have an easier life to integrate. So, but we cannot forget about the previous steps. So one of them is when we need to create models for our real world use cases, typically that this has been done with GML, which is a very, very powerful tool, maybe even too powerful for its own good. And then we have the implementation of the middleware, which needs to understand those models and make them available. So here we made quite a nice progress, because initiatives like Inspire make sure that you have a common model for a lot of things. And we also have now an API, in this case the OGC API features, which will provide that way in a modern way that will allow us to implement applications that will consume, query, and use that data. Okay, so now looking a bit more into the details. One of the problems, one of the challenges, let's put it that way, is that when we have these complex models, typically we store them on relational databases. We can have more, exotic storage like MongoDB, HBase, things like that. The point is we have our data stored in a certain schema, and we need to comply with the target schema, because that expectations will happen somewhere. So when we provide the data, the people in the other end, they need to understand which attribute they should read, they should use to get a certain value. And this started the discussion about the output formats. So if you have been attending this Inspire conference, as you may have seen, there is a lot of discussion about new output formats. So we have GeoJSON, we have the GeoPackage one, which is quite common. And well, there is also the other ones that are still in place, like GML. And we have also things like JSON-LD. And this raises a bunch of questions. So I already have my data prepared for GML. I already have all that mapping done. I need to support multiple use cases. For example, we need the full power of GML when integrating between systems because we need to have access to all the attributes. When creating, for example, providing data for a simple web application, which only needs a subset of the attributes, GeoJSON will be perfect. If I want actually to provide all the ontology associated with my data, I will need JSON LD. So multiple outputs, different use cases, okay? So how does that work in practice? Do I need to create mappings to all of them? Do I need to reinvent the wheel every time? So one of the things we are also working in the context of this project is that we are changing a bit the game. So we are saying that, look, at the beginning there is a full powerful mapping that defines the full mapping between the original data store and the schema we know, okay? Or actually we can actually easily guess it. And then we act on templating. So for example, I have my powerful mapping and I want to obtain a JSON LD. Instead of mapping all the attributes, no. I will focus exactly on the output I expect and I will just say, look, at this place, I want to have this value. And it will be the job of the middleware, in this case your server, to understand this templating and to produce the expected output, but also be able to understand these queries. So here we can see a real example. So here, for example, in this JSON LD templating, we wanted to output the location in a specific format. And here we go, we get this result. And importantly, when we'll query the system, we can actually use those properties and all the models will be automatically translated. We are trying to go one step further. So for that initial powerful mapping, we are creating a new type of smart store, which will work initially only for relational databases, in this case PostgreSQL ones, which look at the database metadata and will propose a mapping. And basically the user will need to perform a basic pruning, like I don't care about this table, I don't care about this column, and that's it. Then all the things that we need right now to do manually of that original mapping will be done. And instead of doing the mapping for the 1000 available attributes, it will only be to be done for the output formats we actually need, focus on the attributes we actually need, and following what we see is what we get approach. And that's all I had to say. I will give the floor to the OGC API Simple implementers.
Thank you very much. I will just share my screen. Can you tell me when you see it?
I can see it.
Perfect.
Thank you very much. Okay. Good
Now,
evening.
can I introduce you quickly? Because I'd like to.
Yeah, sure.
Okay, thank you for taking over so quickly. I love the self-organization of this group, but just to explain to everybody else where this is coming from. I mean, when we had put together this project, we had nicely organized, we will be providing OGC API features via GeoServer, sensor things via Frost. And as is so common with commission projects, you have everything nicely lined up and a nice budget, but then they want a little more. And JRC really wanted to see how difficult is it to implement OGC API features without any prior knowledge. And we managed to get this sorted. We identified 2 brilliant students from an IT vocational high school in Vienna. And at the start of this year, we threw the basic specification links at them and more or less asked them to perform a miracle. And they have. And now I would like to introduce Lucas Gebler. This boy has some serious potential. Lucas, now you can tell them what you have done. I needed to introduce you.
Thanks, Kati. So I have today to have the privilege to tell you more about the OGC API Simple, but first I will talk about us, the developers. Just like Kati said before, we are 2 17-year-old computer science students from Vienna with a passion for web development. And before starting developing the OGC API Simple a few months ago, we never had got any experience with GIS. The order and goal for the OGC API Simple was to implement the OGC API for simple features, according to the specification from October 2019. We split the order into some tasks. We needed to implement a REST API which conforms to the requirements of the specification. The API should return JSON and GeoJSON, so we needed to look up what GeoJSON was, as we have never worked with it before. But as there are not so many big differences between JSON and GeoJSON, there was no problem and the research didn't take so long. Besides the API, we implemented an admin dashboard where several details can be adjusted, but I will tell you more about this later. So what does the OGC API Simple do? Let me explain this image for you. First, the OGC API Simple queries all the connected Postgres and Spatialite databases. Then the responses are processed, parsed, and will be returned as a JSON with the requested data in the format of simple features. You can also select HTML output, but I will explain this later. As it is defined in the specification, collections, items, and details to both of these can be requested from the API and can also be filtered. Now I will tell you more about the technologies we used. So the backend is written in Java, or to be more exact, in Spring, the Java framework for backend applications. The frontend is written in Angular, the open source TypeScript-based framework from Google. The complete application is being deployed within Tomcat using a Docker container. All in all, we could say that the application uses a set of different open source tools. It was the first time for us to use Spring, but as we learned Java in school for 2 years, it wasn't quite hard to understand. In our private projects, we've already used Angular and Docker before, so this also was nothing new to us. But because we haven't used Tomcat so often before this project, we needed and got a little help there. So the screenshot you see now is the landing page from the API. In the navigation bar at the top right corner, you can see a login link. After logging in with the admin credentials, the user will be redirected to the admin dashboard, which I will show you later. Under the heading, there are 2 boxes which say Conformance Declaration and Feature Collections. Both of them are links to the associated pages. The conformance declaration is just, as you heard earlier, is a JSON file which contains links to the API specification. When clicking on the Feature Collections link, you will be directed to the HTML view of the feature collections. Under these 2 cards, there are 3 useful informations. There is the API definition, which is available as JSON and HTML. Then there is a link to the Inspire page and one to the OGC API specification. After these informations, there is the map. In this example, you can see that the collection INSP_airspace area is selected in the column next to the map on the right-hand side. And in the map, the airspaces are displayed. It is possible to select more than 1 collections, then they all will be showed in the map. Besides that, the user can choose between 2 layers, so different styles in the map. The first one is the OpenStreetMap, which is shown in the screenshot, and the second one is a layer provided by AustriControl, where only the federal states of Austria are shown. After logging in, a drop-down with options appears in the navigation bar. You can see it in the top left corner. There are 3 links. The first one, which says Connector Properties, redirects the user to a page where the details of the added connectors can be changed. The second link, Connector Management, redirects the user to the management page. All of the added connectors are saved in a config file. After adding a connector, it will show up on the dashboard. The third and last link redirects the user to a page where the admin password can be changed. So now to the dashboard itself. In the top left corner of the dashboard, you can see a drop-down. There you can select the connector from which the collections should be showed. When selecting a new connector, the associated tables will be loaded into the left table. So under the dropdown, there's this table thing, and there the tables will be loaded. When selecting a collection, the associated columns will be loaded in the same tables thing on the right-hand side. When selecting this exclude checkbox for a table or a column, it will be excluded from the API. In the input field under the tables, where all of the tables are displayed, a collection name can be entered. This name then will be used in the API. For example, when entering the collection name airspaces for the table INSP_airspace area, This name will be displayed on the landing page in the column next to the map. When assigning property names in the input field under the columns, those names will also be used in the API. All of the collection and property names are saved in a config file I mentioned earlier. Under the forms to assign collection and property names, there is another form with the heading Write SQL. In this form, the user can execute SQL queries against the selected database and create views, which then will be added to the list of collections. It is possible to edit or remove the view after it was added to the list. In this screenshot, you can see the HTML view of the API. This is the page where you will be redirected to when clicking the Feature Collections link on the landing page. All of the collections, no matter if they are from a Postgres or Spatialite database, are displayed here. And all of these collections are loaded directly from the API, so the JSON file which you get from the API is passed here. As I've mentioned earlier on the dashboard, collection names can be assigned to the tables and then they will be used in the API. In the example I mentioned earlier, when assigning the name airspaces to the table INSP_airspace area, it would then on this page on number 2, where now it says INSP_airspace area, it would then say airspaces. Besides only the collection names, some useful links are also shown. The first link under the heading Feature Collections is the link to a JSON view for this exact page. Then there are 3 links for every collection. The first one is a link to the JSON view of the collection itself. The second link will redirect the user to the JSON view of the items. The third and last link will redirect the user to the HTML view of the items. On this screenshot, you can see the JSON view of the HTML page I've showed before. All of the collections are shown here. At the second collection, which starts about in the middle of the screenshot, you can see that some properties for this collection are also shown. For example, in the bounding box, the B box. But all of the details for each collection are provided in the view for the collection itself. The ID is the name of the collection, and as I've mentioned before, when assigning a collection name on the dashboard, then this name will be displayed here. So that's the OGC API simple, and thank you very much for your attention. And now I would like to hand over for Hilke van der Schaus for his presentation.
Thank you. I'll also start sharing. Yes. Can you see my screen?
Yep.
Yes.
Excellent. So the next is a bit an explanation of what this OGC Sensor Things API is. In short, it's the successor to the Sensor Observation Service. We all know that, I think. It's the OGC standard for sharing observational data. And SOS is by now getting a bit older, and it was time for a rethink. So the Sensor Things API was introduced, and it was standardized and published in 2016. So it's almost 4 years old now. The Sensor Things API is a full RESTful service using JSON for data encoding, and it, in contrast to the SOS, it has full editing for everything in the service. So you don't need anything except Sensor Things API to both get to your data and manage your data. It has a rather sensible data model, which is shown on the right. I'll get to that in a bit. It has extendable properties, so you can put in any data you want in there, and not just limited to the fields that are defined by the data model. The Sensor Things API has a powerful query language that can query across the entire data model. So you can ask for all things that have measurements for a certain observed property, or all the features of interest that are linked to a certain thing, things like that is also possible. It's very scalable. We've got installations with thousands of stations and millions of observations serving data. And it's very understandable. just like Sylvain already said, the way of the web is to follow links. So also in the SensorThings API, you can follow links to all your data. So a bit about the data model first, before we get to a little live demo. The central thing of one of the core things of the SensorThings API is the word thing, which you see in the middle on the left. And a thing has a location, and a thing can have historic locations if it moves. So if you define your thing to be, for instance, a car, and the car is moving, you can actually track where the thing was. But in many cases, your thing is, for instance, environmental monitoring facility, and those tend to not move, fortunately. The next important thing of SensorThings is, of course, the sensor, which is in the top left, and that describes the device that, or the entity that made the observations. That can be a hardware sensor, but it can also be a human being. If I look at a bridge and say that bridge is blue, then that's an observation. And in that case, I'm the sensor, or my eyes might be defined as the sensor. The next important thing with observations is, of course, the observed property. What property am I looking at? So that tends to be temperature, for instance, or in the case of me looking at the bridge, it would be the color. And then there is a data stream. And a data stream is a collection of observations for one thing, one sensor, and one observed property. So a data stream is a grouping for observations. Then, of course, I mentioned, yes, observation. There are, of course, observations in the SensorThings API, because that's the actual goal of our whole exercise, to share observations. An important detail there is, for instance, the result can be anything. It can be a number, which in many cases it is, but it can also be a piece of text, or it can be a complex JSON entity if you need it to be. And each observation is linked to a feature of interest. And in many cases, the feature of interest will be the same as the location of the thing, but it doesn't have to be. The goal of the feature of interest is to link the observation to a specific geolocation. And the reason that it's separate from the location of the thing is that if you have a moving thing that's measuring the temperature of the outside, you want to be able to quickly find, well, which observations were made in a certain area. And then you don't want to first find out, okay, when was my car in that area? And then, okay, that was more or less that time frame, and then searching the observations, that's too complicated. So therefore, the observation is directly linked to the location where that observation was made. And another case where that's important is, for instance, if you have a remote sensing, where the thing is measuring, or the thing is not at the same place as the location. If you have a camera that's pointing at a distant object, you might have observations. The location of the observation might be very different from the location of the thing. So that's very shortly all the entities. Let's go into how to get data from the SensorThings API service. And of course, the easiest way to do that is live, because we are all very brave and things are always working fine. An important bit about the SensorThings API is that the version number of the service, of the specification, is in the URL of the service. So in this example, URL server.de/frostserver/v1.1, that already indicates for both client and server that we're dealing with version 1.1 of the standard. Version 1.1 is not officially released yet. It's been released for public comment only 2 days ago. So it's very, very near. The official released version at the moment is version 1.0. But in my examples, I'll be using version 1.1 because it's the future, and we like to look ahead. So if you request a URL with just this version number, as in this example, this is a public example. If you want to have a look at it, you can for yourself. This service has air quality data for all of Europe. about 260 million observations. So if you just request the version number, you get a document that explains you what the server can do. It has a list of all the entities and where you can find these entities. So this is again the follow the links principle. And below that is for version 1.1, this is new in version 1.1, is the list of what the server can do. So there's the conformance classes that the server implements. So for instance, this server implements multi-data stream, and it can do, and it has some custom extensions, and it has MQTT endpoints. So then if you add, for instance, /things in the URL or follow this link, then you get all the things in the search. So here in the top, I hope my screen is not my text is not too small. If it is, give me a warning. So right now, this is a long list of JSON entities. Each one is a thing. So this top one is a measurement station with an official name, and it has some properties. These are all custom fields. They are freely defined, and for this use case, we defined these properties. An important one is the IoT ID, which is the server internal identifier of the entity, in this case of the thing. And below that is a self link. If I follow the self link, you can see that it adds in brackets the ID. And if I follow that, I just get the one thing. So that, for the example, cleans up the screen a bit. So in the data model, let's have a quick look there. We can see the thing here has links to data streams, historic locations, and locations. So if I go back to my data example, I also have links in my JSON document to the data streams, the locations, and historic locations. There are also multi-data streams, which is an extension. And if I follow this link to the data streams at IoT navigation link, I get the data streams that are linked to this specific thing. In this case, it's one. That's a bit boring. Let's find a different thing. Data streams, also one. Oh, well, okay. And this data stream, once again, has a self link, which links to just this data stream, because in the URL, you can see this, the URL is now to things 1791/data streams, which is the data streams of things thing 1791. And each of these data streams has, of course, a link to itself directly, which then goes to data streams 6104. And the data stream has a link to an observed property and to observations and a link back to the thing. So the data stream links back to thing to the thing. So if I follow this link, I get back to thing 1791, and then I can link back to the data stream. So you can follow the links and find all your data. So there's also observations, and then you get all the observations. Okay, back to my things. Oh, of course, this service has more things than I can display on one page. So that's why every sensitive service has paging on every page that potentially returns more than one entity. There is paging. So here I have all the things, and there's a link at the top, next link, that takes me to the next 100 things. The server by default returns 100 things, and then the next page has a link to the next 100 things with a skip. I can also say, well, 100 things at a time is too much for me, and in that case I can say, for instance, top is 10, and that indicates that I only want 10 entities. Now my list is a lot shorter. And also my next link now has top is 10 and skip is 10 to go to the next 10. Of course, it can be nice to know, well, I'm asking 10 at a time, but how many are there in total? For that, you can and say add count is true. And then I can see here there are in total 4,382 things in this service, which in this case are all measuring stations. And then you know how many pages you might have to go through to get all of them. The next interesting thing is it might be that I'm not interested in seeing all the data of all my things. It might be that I just want to know, okay, give me the IDs and the names. For that is the select field. If I say select is ID, name, I only get the ID and the name. So that can greatly reduce the amount of data that I have to transfer to get to what I want. What's next? Next interesting is it's of course impossible to filter. If I have, for instance, observations, I can say, well, filter me the observations with a result greater than 5. And filtering is not limited to just the entities themselves. So I can also say, okay, give me all the things that have data streams that have a result greater than 5. And then you filter your things on properties of the observations that are linked to that thing. And the next very cool thing is expand. So very common is, of course, that, okay, give me all my things, but I want to display them on a map. So I also need to know the location. And I might also want to know directly the last observation made at that thing. And for those things, you can do with the expand keyword. So if I say expand is locations, and I get my things. And for each thing, I also directly get the location of that thing. And that can be combined with all the other properties. So if I only want the name and the ID of the location, I can say, okay, and for that location, I only want the name and ID. And that also combines with filters. So you can say, okay, give me the data streams, but only those for a certain observed property. And then the observations, but ordered by phenomenon time, and then only the latest. So all in all, the querying capabilities of the Sensor Things API allow you to get with one request exactly the data you need for your use case. This was a very short tutorial in getting data. There's a longer tutorial on our website, which is linked on the bottom here, and also linked in chat. So then editing data. You can create new entities by posting to an entity set. So if I make a post to things, I can create a new thing. By doing a post on data streams, I can create a new data stream. But I can, for instance, also post to things/data streams or thing x/data streams, and then I can specifically make a data stream for a certain thing. Or I can post to data stream x/observations, and then I can that way create a new observation for a given data stream. And you can also update all entities using patch or put. So with patch, you can just send the properties that changed. So if I make, if for an observation I noticed that the result value was wrong, I can send a patch with only a new result, and the rest of the properties will not change. And with put, you can completely replace an entity. So if almost everything changed, you can use put. And you can also delete entities again from a server with the delete keyword, HTTP keyword. So if I make a delete on thing 42, then thing 42 is deleted. And that also delete all the dependent entities. So a data stream has to have a thing. So if I delete thing 42, then all the data streams of the thing will also be deleted. And an observation has to have a data stream. So then if the data stream is deleted, the observations in that data stream are automatically also deleted. There are several implementations of the SensorThings API, both client and server implementations. Within the API for Inspire project, we use the Frost server because that's the one we made. But that's not the only player in town. The Frost server is one of the reference implementations of the OGC SensorThings API. And it's a complete implementation of the entire specification. And it also by now has several extensions. It has, for instance, an CSV extension, so you can get your data as CSV files. And it has a GeoJSON extension, so you can get your data as GeoJSON, so you can directly display it in, for instance, QGIS or any other GIS program that can display GeoJSON. A Frost server is open source, LGPL. So there are also several other projects that use Frost server as a library to make it easier to expose their data as a SensorThings compatible data. It's implemented in Java using Tomcat, but there are also Docker images available. And Frost server has horizontal scalability. So if one service is not enough for your load, you can add more than one Frost server next to each other on the same data backend. There are several ways to deploy Frost server. The most common way is to use a Frost managed database. That means that Frost itself deals with its own database. It creates its own tables, and you add and manage your data using the SensorThings API itself. That's the easiest way to deploy the SensorThings API service. You only need to know SensorThings API itself, and the databases can be treated as a black box. But in many cases, you might already have a large database with observations in it, and you might not want to duplicate all that data into a new service. And then you can all deploy Frost as well using database views. So, for instance, you can make views that mimic the tables that Frost makes itself normally, and those views directly access your data that you already have. And that way, you don't have to change anything in your data flow and your data management practices. You can use your existing database and still expose your data as SensorThings API. So we've got several demo services. There is a free-for-all demo server that everybody can read, write, and test on. That's ogctest.docker01. The link is on there. And so everybody can use that to try out applications and to write. There's of course no guarantee that your data will stay for very long, because everybody can also delete everything again. But for a quick test and to get a feel if how it works, it might be useful. One of the services we have is the one I just used for the demo, the European Air Quality Data Service. That's a Frost server with 4,300 measurement stations across all of Europe. It has about 18,000 data streams measuring 9 different observed properties. And it has about 265 million observations by now. And there's also a nice viewer. Let's try that link. This is a SensorThings API viewer that shows simply all the things on the map. As you can see, there are quite a lot of measurement stations. Some of our European countries also have overseas areas, so there are some interesting overseas measurement stations. And if you zoom in, you can get down to entity level. You can click on a thing, it will give you the properties of the thing and show the data streams. And then you can simply show the data of that station. And here I just clicked on the full range, so it shows all the data since 2018. And you can zoom in as you want, and it will load data on demand. Where was I? Okay. And lastly, there's a cool demo service with the demography data. So that has the total population and the population density for all NUTS levels 0 to 3. So if you want to know how many people are living in your community, you can use that service to query the SensorThings API service to get the data for your community. And that concludes my overview of the SensorThings API and Frost server. Kati, back to you.
Okay, let me see how I can get the sharing back.
You should now have it back.
Perfect.
And I noticed there was a lot of pinging going on in chat.
Somebody needs to copy the chat protocol. Alex, is that somehow stored at the end? Because there was very interesting stuff going down. Somebody else, please follow that now because I'm having problems seeing it. Okay, to finish off this presentation, I will be explaining the various, what we've been calling data nests, where, I mean, this is a term I invented. I needed some way of describing these sets of co-located complementary data sources. And it makes a lot more sense than reusing a word with a different meaning. So we started out with 3 of these data nests. First one we've been calling ARI Austria. It doesn't quite make sense, but it almost makes sense. We've got the air transport information coming from Austria Control. I put actually the OGC API endpoint out of the chat while I think Nuno was talking. That will be complemented by Meteorological Agency from the Austrian Meteorological Agency. That's still a work in progress. Actually, no, I'll go into the details later. Then we've got the various smart sensors from the city of Hamburg. We've got the cross-border work from France and Germany, and then we've got the COVID ad hoc. Finishing what I already started with the ARI Austria bit. So we've got the OGC API endpoint operational on the transport network data. There you can also actually compare what does the same data source look like using WFS2 and OGC API. It's both running off of the same GeoServer. They've been kind enough to deploy the GeoServer extension, and with one bang, the data was open. Austrian Meteorological Agency, as I've stated, is still a work in progress. Next will be City of Hamburg. Sonja, Hilke said you would present this.
Yes. Do you hear me?
Yeah,
No.
I hear you. Sorry for having hit the wrong thing again.
So, shall I take over, or do you want to say some more?
I would leave the slide, but I will let you speak. I will not mute myself, because if I mute myself, I click on the next slide by accident.
Okay. So, in Hamburg, we have implemented a sensor and real-time data. We started with some data sets. The e-charging stations for electric cars we have in our system, I guess, since 2018. And also we have our rental bike system in there, where you can view what kind of bikes were available at the stations at what time. And we also have data from the energy campus of the Hamburg University of Applied Science, where you can see how much energy was produced and consumed by different types of engines. For example, a photovoltaic plant. And what comes next is that we want to implement the traffic light signals in there, and also the amount of vehicles at the crossings. So what we plan is a real-time counting of cars, vehicles, bikes in real time in our city with a cyclical FDS system. What would be interesting for our listeners maybe that we also thought about the Inspire components. We used the environmental facility class for this. No, environmental observations, I guess. Well, okay, and there are some points we integrated in our properties field. For example, media monitored, as Silke showed in one of his data stream links. But what we did, we implemented some new media values in there. Since we have a lot of transport issues at Hamburg that we publish in real time, so we put in a category transport. And we also let me see, what do we have? The result nature we also use very good, and there are 3 types: processed, primary, and simulated. And this is actually really handy because we for some prototyping we use simulated data to see how, for the visualization, how it works if we don't have the real data in there. So it's a really nice field actually in Inspire. And we also have the namespace in there, and to connect the dataset with the metadata set in the metadata catalog and Metafair or the Hamburg metadata catalog. Yes.
Thank you very much. I hadn't even realized that you're actually utilizing the Inspire specification and extending that.
Yes, we were also thinking about the process type, but the description in the Inspire was so not understandable that we decided to skip it and just use and not overload our data streams, because the bigger it gets, the harder is the download. And if there are too many items, well, we wanted to have a slim JSON object.
Where if
Yeah.
you have questions on that, if you say the description was so bad you could not understand it, then we have done something wrong. And this is not a statement to everybody here. If you find a statement in the data specifications you do not understand, please come to the Inspire forum and ask us. There may well be somebody who can still remember writing it and might even know what they were trying to communicate when they were writing it. It wasn't always easy. So please pose such questions, because it can only help us to make things better for the future for everybody.
Well, regarding the implementation now of the Inspire fields in the data streams, and well, we did this now because we said, okay, maybe it comes, maybe it doesn't come, but we don't have to change all of our objects again and again. So we implemented already some of the features of Inspire in there, but sensor data were not are going to be in discussion in the next year or this year in the different forums. So we wanted to also state an example how it could be easily implemented in the real-time data sets.
We're also, just a further compliment, I find so beautiful that Hamburg is not just doing this, but is making it openly available. I mean, I'm sure a lot of other cities are also doing this, but they don't even tell us about it, and they do not give us access to their endpoints.
Yes.
Okay, pushing forward because we're running out of time. Sorry.
Yes.
Sorry on that.
So thanks that we could present our stuff. So go ahead.
Okay, thank you very much. Next on is Sylvain on the, is Sylvain or Hilke? Who of the two of you is doing the French cross-border thing? Let me put up the slide so you two can fight over that one.
I'm pretty sure I was not assigned to this one.
Sylvain, then it's up to you. Or have we lost him?
I'm here.
Please,
Nicely. Okay. So the Franco-Germanic flow involves the various data providers Katy introduced in the intro. So I guess there is no need to restate that again. There is the link at the bottom of the slide to link to LUBV endpoints. Can you move to the next slide, please? Yeah. So I think it's better to have an overview here. Then you will have the endpoint address on the GitHub link that is shared. So it's basically information with about water surface water, river plus water quality station and quantity stations, and yeah, and observations, of course. So a snapshot from a graph. For the first surface part, and for the groundwater part, it's aquifer, hydrogeological units. Their groundwater monitoring facility. I don't remember for the German side, but for the French side, we're providing groundwater level, but also temperature and conductivity, salinity of the groundwater. When the sensors are fitted with them, now for the French side, this will be near real-time data flows because we're connected. We managed throughout that project to connect to those flows, but then given the flexibility of ONM and sensor things API spec, we can later provide validated data, of course. And on the right side of the screen, it was a tentative screenshot to represent a flood area. So, and the playground is a Rhine River. So try to have some coherence around that. So part of the flows will be, like when it comes down to describing real-world features like river stations, aquifers, and stuff, will be OGC API features, and also part in sensor things and observation, of course, will be provided according to ONM and using sensor things API as an endpoint. I think that's all for me.
Thank you very much. Now for our final data flow, so continuing off from the hydro things that Severa has just described, I'm not going to go off to the various ad hoc feeds we've been putting online, which, I mean, if nothing else, they're a nice illustration for how easy it really is to expose data, at least with sensor things. This has all come up on the side just because we thought it would be cool and would make sense. So we'd start, the original plan had been to put all of these hydro things online. But then came COVID. I kept reading about the links between air quality and COVID intensity. I'd initially done the European air quality reporting several years back. I know where the data is. I know how hard it is to get. And so a few days later, we had air things. Started out with just the Austrian ones taken off of the Austrian Inspire services, and based on popular demand, we then went into the EEA's data resources and now have most of Europe online in real time. Then when we're working on this, we got in an interesting resource from the Technical University of Stuttgart, where they've actually been putting the real-time COVID data on a Sensor Things API. And that was the perfect complement to where I had been thinking. So again, it also shows for what type of data resources one can use sensor things. Both the hydro and the air things are more classical things where you would expect a sensor behind it. The COVID things is sitting on hospitals' databases, actually mostly coming from Johns Hopkins and the German Robert Koch Institute. But then I realized we need demographic information because the number of ill doesn't tell me anything if I don't know the population of that area. Again, I know where Eurostat hides the data. I know how hard it is to put that into a spatial context, but I know the missing links and the demography things. That was a week or two ago over the weekend. This took about 2 days. So it is exceedingly simple to get this online. Here we've got all of the endpoints for these things. They're available to play with them. And unfortunately, we're hitting the end of our time, but the real goal of all of this is to use this stuff. So, I mean, we've made quite a lot of data available. We also have some good guidance material now of how other people can make this data available. It looks very promising for really creating an accepted good practice in Inspire and having this as a valid way of putting this online for Inspire. However, we need to reach the critical mass of the good practice. I think Alex has put some information on the chat there. So what I would really need from all of you would be any input you can provide with anything you've been doing playing with these endpoints. And B, anybody who's interested in making their data available via these, please get in touch. We don't have much support we can provide, but we can provide a little bit. So right now is your chance. Soon that chance will be over, and then you have to pay us. So now I'd like to open the floor. Who would be interested in doing what with what we have shown?
Don't be afraid to turn on your microphone.
Don't try to show your hand because I cannot see the participants. Martin, what environmental media would you consider? I know I've done your meteorological data years ago as my first proof of concept.
Can you hear me?
Perfect.
Okay, thanks a lot. Just briefly, we would love to get in touch with Slovak Hydrometeorological Institute. And secondly, we will see, but also Statistical Office might be the second area where hopefully we might get some data and later on to see, hopefully with your help, how to actually use results of your work to justify that this is really direction which makes sense to support. Thank you.
This is Jürgen here. Can you hear me, Kati?
Mhm.
There were several questions in the chat regarding the metadata description of the sensors. Maybe Hilke can say something about this.
During my talk, I'm not sure I actually understood the question, but the sensor itself has a field metadata, and you can put anything in there you like. In many cases, that is for simple sensors, that's just a link to the PDF fact sheet of the sensor itself. But you can also put in a complete sensor ML description if you have that available. I don't know if that answer that was the core of the question, or if it was about something else.
I mean, it's often confusing because metadata refers to so many different levels. Metadata could describe the service, it could describe the data set, or in this case, it's really describing one little detail of the data set. So we're not talking about the type of metadata you would find in a catalog service.
No, exactly. The metadata field in the sensor entity is really the description of the sensor itself.
Got a chat. No, find sensors via metadata in portals. I mean, theoretically, the JSON is crawlable, so Portal should be finding this.
Exactly.
It's not missing.
But I think find sensors via metadata in portals, that's what we've integrated in our metadata catalog. So what we have described the data set, and as a link we put in the total query. For example, since we're putting in the charging station, for example, and the bike stations in the same API, you would get just the query by query the service name and the layer name, and therefore you get back as a response the data set just for the charging station. That's something you put in the metadata catalogs. So if you're looking for certain sensors via metadata in the portals, you would need to describe the metadata set and put in the query as a link to that specific sensors. So that's the solution we have found so far, implementing different types of sensors in our urban data platform.
Do we need to talk further on metadata, or I mean, one major issue is exactly as currently discussed, the discoverability. We're still very focused on being discovered by catalogs. The more we can expose it in some more readable form, the more likely we are to be exposed by other portals. Further questions? General impressions. Can anybody imagine using this stuff?
There is a question of Martin about client support in QGIS and web clients. Maybe, of course, for the APIs, maybe this is something that we can take.
I think this is up to Hilke and Nuno.
As far as I know, most client or desktop programs don't do sensor things yet. That's also the reason why Frost has the GeoJSON extension. So if you can formulate your query to return as GeoJSON, and then you can actually feed it into something like QGIS. And since Sensor Things API support this extends concept, you can actually expose any data in the service as GeoJSON. So that's the easiest way. But it would be cool if QGIS had an actual Sensor Things API client, but I don't think anybody has worked on that yet, as far as I know. But
we're also considering, I've got an intern this summer, and it looks like he will be doing libraries for easy integration of Sensor Things into open layers and/or Leaflet.
I would like to, as you said that, Kati, I would add that we are providing the master portal as a Geoportal client, and we included already the Sensor Things API in there. So we can not only show like the static data from the Sensor Things API, we are also including the Impurity extension, so that also the live data is pushed towards the web client portal. So the Sensor Things API is supported by the master portal as an open source client, and you'll find that the link I posted in the chat. So it's on masterportal.org. And fortunately, I think it's not in English yet, but we're working on the translation. But it's open source, and you can freely use it.
Cool, thank you. Further questions? Okay, and alternatively, you can get in touch with us via our website. The mail addresses are at the end of the presentation. The presentation will be shared. I'm assuming that many people are not daring to make statements in public now. I often also don't. So anybody who is interested in either deploying their data via these APIs or also experimenting with the usage of them, check out our websites, get in touch with us. And I'm very much hoping we can reach the critical mass to really make this mainstream and inspire. If no further questions, I would bring this session to a close. Okay, in that case, I thank you all for your attention. And as stated, further questions, get in touch. And hope to see you, hear you, read you soon. Bye-bye.
bye-bye.
Bye.